To start off this birthday polynomial, let's take a look at the x-intercepts. If you wanted to find these algebraically, you would set all y values equal to 0, but for time's sake, we could find the x-intercepts graphically. Let's start off with the most obvious one, which should be on the point 0, 0, right in the middle. The other two are a little more tricky since they aren't on an integer, but you can use your graphing calculator or online resources to assist you. The intercepts end up being negative 0.653, 0, and 0.653, 0. The x values are opposite of each other, a characteristic coming from the parent quadratic function. With that, we move on to the y-intercept. In this graph, the y-intercept is also an x-intercept, which is located at the origin point 0, 0. Examining the graph, there does not seem to be any relative or absolute minimums or maximums. You could determine this since the graphs extend infinitely upwards and downwards as seen on the graph here. To find the vertical asymptote in this polynomial, set the denominator not equal to 0, as anything divided by 0 is undefined. So then for this equation, you would put 5x cubed plus 20x plus 2 is not equal to 0. Next, you would subtract 2 from both sides, leaving 5x cubed plus 20x is not equal to negative 2. Divide 20 on both sides, and simplified, you get 5x cubed is not equal to negative 1 over 10. Next, divide 5 to both sides, getting x cubed is not equal to negative 1 over 50. Now, since this exponent is to the third power, we will need to take the cubic root instead of the square root. So then you would be left with x is not equal to the cube root of negative 1 over 50. Though it looks pretty atrocious, we have graphing calculators, so then we could get the decimal answer of negative 0.271442. For the increase/decrease of this polynomial, we look directly into the asymptote. Where does the asymptote start? The asymptote starts at negative 0.271442. There would lie the minimum and maximum of the increase and decrease, as it brings any movement to a halt. From the left, the graph seems to be decreasing to the asymptote. Therefore, it is going to be from negative infinity to where the asymptote lies. Going to the right, however, it extends all the way into infinity. Therefore, it increases from the asymptote to infinity. Last but not least, the boundedness. There is none.